Okay, we've been asked to generate the first 5 terms of these two sequences with very, very similar nth terms. In fact, these are the two ways, or the two most common ways you would express a geometric sequence by nth term. There is one other way, but I'm not going to talk about that now. It only works for special sequences. So 5 times 2 to the n. Remember, the first 5 terms, n is going to be 1, 2, 3, 4, 5. So u1 equals 5 times 2 to the power 1, which 5 times 2 equals 10. u2 equals 5 times 2 to the power 2. 5 times 2 times 2. 5 4 is 20. u3 equals 5 times 2 cubed. 5 times 2 cubed. 5 times 2 times 2 times 2. Or if you look at what you're doing, you could just double that. u4 equals 5 times 2 to the power 4. So 5 times 2, 10, 20, 40, 80. And finally, u5 equals 5 times 2 to the 5, which is 5, 10, 20, 40, 80, 160. So these first 5 terms are 10, 20, 40, 80, 160, and it keeps going on. The second one is slightly different. 5 times 2 to the power n minus 1, so whatever n is, you take 1 away, and then you do it like that. So the first one, n is going to be, well, n is 1, so n minus 1 would be 0, so u1 would be 5 times 2 to the power 0, or 2 to the power 0 is 1, so 5 times 1 is just 5. u2 is going to be your 5 times 2 to the power 2 minus 1, which is 1, and actually from there we can then start to use the sequence over here. u3 is going to be 5 times 2 to the 3 minus 1, which is 2. u4 is going to be 5 times 2 cubed, which is 40, and then u5 equals 5 times 2 to the power 4, which is 80. So the sequence is 5, 10, 20, 40, 80. So you can see these two sequences they're exactly the same, apart from one crucial, but they start in a different place. So they have the same common ratio, and a lot of the numbers are exactly the same. It's just this one, because it was 2 to the power n, it started on 10 and then doubled from there. This one started on 5 because of this n minus 1. It just started one number earlier and then doubled from there. So they're very, very similar sequences.